The last part of section 9.2 is similar to the last part of section 9.1. It wants us to determine minimum sample sizes for a particular margin of error. So very similarly, this time the margin of error E is the t critical value, and again times the standard deviation for a mean. The only difference is we don't know the sample size, so we can't look up the t value. So instead we use the z critical value times the sample size. So pretty straightforward, very similar to how we do that for proportions. In your formula sheets, that very last bullet, the very bottom, it says to estimate the population mean with a margin of error E at a particular confidence level is n equals the z-score, or the z critical value times the standard deviation over the margin of error, and the whole thing gets squared. So it's already rearranged this for you so that you can just solve. So instead of going through all the algebra this time, we're just going to jump straight to the adjusted formula. So here it is. We have the sample size, we have the critical value times the standard deviation divided by the margin of error, and the whole thing gets squared. Pretty straightforward with the adjusted formula. So here's an example of that. We want to estimate the miles per gallon of a 2007 Ford Taurus, again with that same scenario, that same set of information, with 95% confidence within a 0.5 mile per gallon margin of error. What is the minimum sample size necessary? So this time they don't give us a percentage, they just give us the margin of error. And we're going to use the same set of information we were using previously. Let me find it. So the same Ford Taurus information. So from the very beginning of this section, we know the X bar and we know the standard deviation. We're not going to worry about the sample size this time. So we have, where to go? N equals the Z critical value times S over E, and the whole thing gets squared. So we have the critical value for 95% confidence, which is 1.96, times the standard deviation that we had previously, 3.21, over the margin of error which they gave us in the problem, and the whole thing gets squared. So if I type that in, remember the critical value comes from the chart. We got the 1.96 from that little corner chart at the end of the formula pages. That little chart, 95% confidence, is 1.96. So that's where the 1.96 comes from. The 3.21 came from our example previously, and the 0.5 comes straight from the problem. And the calculator knows the order of operations, so you can just type it in. It spits out 158.34, and remember we need to round that always to the next biggest integer, which in this situation will be 159. So very similar, plug and go, not too bad. And I have an extra example for this one. It's from page 417. It is in section 9.2, and it is question number 48 about television. So it says a researcher wanted to determine the mean number of hours per week, Sunday through Saturday, the typical person watches television. Results from the Sullivan Statistics Survey indicate that the sample standard deviation S is 7.5 hours. So they have results from previous surveys, but they do not have a true standard deviation. How many people are needed to estimate the number of hours people watch television per week within 2 hours with 95% confidence? So part A, N would be the critical value times the standard deviation over the margin of error squared, which in this situation the critical value is based on the confidence level, so 95% confidence would be 1.96, times the standard deviation, 7.5, the margin of error is just 2, and the whole thing gets squared. So that gives us, divided by 2 squared, gives us 54.0225, which is 55. So you just plug and chug to get the answer 55. Part B, how many people are needed to estimate the number of hours people watch television per week within 1 hour with 95% confidence? So our margin of error just got cut in half. We want to be more precise. So it's the same values, 1.96 times 7.5. This time, instead of dividing by 2, we're dividing by 1 and then squared. So I like to just hit second enter, change the 2 to a 1, and rerun it. And that would round to 217. So in order to make our margin of error smaller, we have to increase our sample size by quite a bit. So part C says, what effect does doubling the required accuracy? So this is double accuracy. Did I spell that right? ACC. Accuracy. If we want to double our accuracy, we have to increase sample size. It's actually by a factor of 4. The reason we're increasing by a factor of 4 is because in order to make this twice as accurate, if we're going to square it, it actually is going to increase by almost 4 times. So 55 times 4 is very close to 217. So we're actually having to increase our sample size by a factor of 4. If I wanted to triple my accuracy, so if it was 3 times smaller, this would increase by a factor of 9. And again, that's because we're squaring the result. Part D, how many people are needed to estimate the number of hours people watch television per week within 2 hours, so just like Part A, but this time we only want 90% confidence. So we're going to lower our confidence level from 95 down to 90, and then we'll see what happens. So this time we have, instead of a critical value of 1.96, we're going to look up the critical value for 90, which is 1.645. So 1.645 times 7.5 over 2, and then squared. So let's see what happens. Some of you might be able to predict what's going to happen. Put all that in parentheses, and then square it. 38.05, which is 39. So instead of needing 55 people, now we only need 39 people. That means that lowering confidence decreases the sample size. So there are a lot of relationships in Chapter 9. What happens when you increase your confidence level? What happens when you increase your sample size or decrease your margin of error? There's a lot of relationships going on in Chapter 9, and a lot of homework questions are trying to help you find those different relationships. So we discussed a few of them, and there's more in the homework where you can help discover some of those relationships. But if you're going to lower your confidence, you can decrease your sample size. And that might be good for researchers that don't have the money to sample 55 people, but maybe they have the money to sample 39 people. So just different relationships between everything in Chapter 9. That is it for Chapter 9. So it's computing confidence intervals for means and proportions, and then determining sample sizes for means and proportions. So 4 topics in Chapter 9 to practice.